Okay. Sometimes, I probably could have done this all in one video, but sometimes you make have technical mistakes there or technical errors there, and I was having a little trouble on the previous video. So I had to do a second one here as we pick up where I left off. Now, on this second slide here, you see three triangles. You have the original, which I have in gray, and then you have two copies, copy one and copy two. They're both scaled copies. They're both scaled copies. The only difference between the original and copy one is I flipped it over. And when I did copy two, it was kind of the same thing. I made it larger. I made it a scaled copy larger. And I switched its direction. You have to realize sometimes when we have scaled copies, they're not always going to be arranged in the same way. And that's why we're having this discussion about how to find corresponding sides and corresponding points to help you when you're working with scaled copies of shapes. So if we think about this, right, I have my ABC, and A corresponds to D, B corresponds to E, and by knowing my points, I can identify my segments, which is what I do on the next slide here, right? And so when we look at our segments here, we see how they correspond. AB corresponds to DE and GH. AC corresponds to DF and GI. BC corresponds to EF and HI. So by having this corresponding and know what sides correspond to what, then we can kind of like bring in the whole idea about scale, which is what I finish up with. And so when we look at our slides here, right, we have our original triangle, which is 3, 4, and 5 in terms of the units of the sides there, right? And so for our copy one, it's 1 to 1. We just flipped it over. It's the same sizes. And so it's a scale of 1 to 1. So you multiply the original times 1. So 3 times 1 is 3. 4 times 1 is 4. 5 times 1 is 5. Now when we look at copy 2, it's a scale of 1 to 2. We've doubled the size and size. And so you're multiplying each side, the original, by 2. So the 3 unit side times 2 is 6. The 4 times 2 is 8. The 5 times 2 is 10. And so that's where scale works in. Now, just for a little tidbit of extra thought, which might appear in your question that I give you today, if we had copy 2 and we said that it was the original and that the original is now a copy, well, then what we would be seeing is that the scale would be the reverse of that. It'd be 1 to 1/2, because the opposite of doubling is halving. And so just keep that in mind when you work on today's problem out here.